Hello and welcome to this video where we will be attacking Kerberos and we'll be conducting the alternate name service attack. This attack is going to be following the following scenario. Basically, in your enumeration of the Active Directory, let's say you find a server which has constrained delegation, which we'll get into how to enumerate that. But long story short, this constrained delegation leads to your access for a very meaningless service. And so in an effort to gain access to a more powerful service, such as something that provides local access, such as the CIFS, we then use the alternate name service attack using S4U in order to alternate the SPN, all of these things we'll get into, for the TGS in order to access a different service such as the CIFS. In this video, you'll gain familiarity with Cobalt, enumeration tools such as LDAPSearch and ADSearch to discover delegation. You'll be seeing me do some lateral movement utilizing S4U for the main portion of the attack, process creation with Rubeus, navigating through processes, and lastly, credential and token management using inbuilt Cobalt commands. So let's go ahead and get into this lab environment. In this specific scenario, we are assuming that we have access through an assumed breach. And that initial access has been done through, as you can see here, Cobalt. And here we have a beacon. And in order to enumerate for delegation, we can utilize LDAPSearch. And I'll go ahead and put in the command here for you to use, as well as in the description. But before we move forward, I want to explain the significance of the actual property that we're looking for through this LDAPSearch command. This property, msDS-AllowedToDelegateTo, is the property or attribute that is on the computer account that has been modified or configured to be able to delegate. So that computer, once it has this, it's able to get TGS tickets for any user to the service and server that is configured, which in this case, as you can see, we are workstation 1. And by this command, you can see here that we have access to the service time on the computer LONDC1, the domain controller. This is also confirmed by the UAC. Now, let me put in this command and then explain it to you. So in this LDAPSearch command, we are checking the UAC bit mask. And although this seems like it's just a bunch of numbers, I'll go ahead and explain it here using my notes. This bit mask is actually telling a lot. So as you can see here, using bit masks provides the ability to display a series of settings using true and false logic, like binary logic, which saves space and increases the speed, rather than putting all of these strings or whichever format or system to store this information. Instead, we utilize these digits, which is these digits, decimals representing hex values in order to tell this entire shebang. And so as you can see here, it is confirmed that this computer is trusted for delegation. And lastly, I wanted to showcase another tool for seeing all of this, which is ADSearch. So if you're on Cobalt, you'll just execute ADSearch, the binary, through the execute assembly command. And I'll also post this in the description as well, just like everything else. But basically, what you'll see here is another nice view organized for you to confirm who and what has delegation to what. And so as you can see here, our this computer, WS1, web server 1, has the property, and what it can delegate to is time on the DC one, on the domain controller. So now we have established who can delegate to what. The web server can delegate to the domain controller. So let's go ahead and go on that web server to demonstrate this delegation and how to abuse it. So in this specific scenario, we receive credentials and we're able to use those credentials to move laterally to the web server. So the credentials are right here as follows. And because we're on Cobalt, to use these credentials, we can simply use the make token inbuilt command, which will make the token for us using these creds and then impersonate it directly. And so these creds were given to us as part of the lab in order to access the web server. Now, once we impersonate the account, we're able to access that web server who this account has access to. And so we'll do that through the inbuilt jump command. So as you can see here, we're using psexec and we're jumping to the web server using SMB. And now that we did that, we'll see our new host target appear in our targets, in our beacons. And there you go. It's lagging a little bit and now it's going to show up. And by the way, before you do all of this, if you are wondering, well, you know, this enumeration is nice and all, but what about everything else? I do urge you when doing any of these labs to fully enumerate as much as you possibly know before conducting the attack. And that's pretty easy here on Cobalt. Like, for example, we can go to Explore, Net View. We can go to Explore, port scan, launch a port scan. I do need to specify the anyways, you know, if you're on, you can do some end mapping. You can proxy to an nmap if you don't have direct access to the rest of the network. But I just want to urge you to enumerate as much as possible, because when we're doing these labs, we're not doing it for the specific learning outcome that, you know, is specifically designed for that section of the lab. We want to gain as much as possible from all of the labs. And so perfecting our methodology by always reusing our enumeration methods, you know, maybe we have attack methods from previous labs or previous courses, and we want to test them now. All of this is experimentation to reach the actual goal of doing any of these labs, which is perfecting and making your own methodology. And so, as you can see here, we got a system beacon on the web server. And now that we're here, in order to simulate the delegation and abuse it, we need to have a Kerberos ticket for our computer, for the computer who has been configured to perform the delegation. So we'll be using Rubeus in order to triage for the tickets that are currently in memory. So if you're not familiar, once tickets are requested and used, they get stored in the computer's memory. And so what Rubeus does using this command called triage is simply list the tickets that are currently stored in memory. Now, I want to share that the fact that if you're listing tickets, it's not 100% guaranteed that you'll find all the tickets you need. In certain attacks, there will be a time frame where you're able to steal tickets from memory. And for that, I want to share that the optimal is always to monitor if that's possible. Otherwise, you have to conduct a specific OPSEC for a specific TTP, or to emulate a specific kind of threat that doesn't monitor, or a scenario where monitoring is more detectable. But monitoring the memory is always much more reliable than dumping it at any specific time. But in this case, we have the ticket that we need right here with the LUID of 0x3E7. And so we'll be using Rubeus again with the dump command, specifying the LUID that I just mentioned, and the service, which is the TGT, named here KRB TGT, and no wrap, because no wrap will output the ticket in a way that we can simply copy paste it instead of having a bunch of gaps and spaces. So now that we got the ticket, we are now able to use it in our S4U command in our S4U attack. If you recall in the beginning of the video, I mentioned that our delegation is limited to this service called time. Now, time is nice, like maybe if you want to check the time, but if you're trying to move laterally to the domain controller, then we need CIFS, SIFS. If you're trying to conduct an AD attack, that requires LDAP. So instead of time, then we would get LDAP. In this case, we're trying to move laterally, access the domain controller locally. So we're going to be going for the CIFS service. So instead of the main goal of this S4U abuse that we're about to do is to change our delegated access of time to CIFS, which I'll show you allows us to, access the domain controller. So now that we have this ticket, we can use Rubeus again with the S4U command, and I'll explain this command flag by flag. So as you can see here, it finished, but firstly, let's go ahead and explain it, get a little bit of an understanding of what's going on. We used execute assembly to execute the Rubeus binary. Here we specified that the command, the main thing that we want to use Rubeus for is S4U. And S4U is basically that we're going to abuse the S4U functionality in order to get what we want. The objective is to get CIFS on the domain controller. We specify us, the users who we're using, the service that we are allowed to delegate to, which is time on the domain controller. And I'll also get into SPNs and, what are SPNs and what even is this in a sec. The alternate service that we want to change time to is CIFS. And then here is the ticket that we extracted from memory. Now at the end of the ticket, there's also another flag, which is the user who we're going to impersonate. That's the whole point of delegation, is to become someone else to be accessing what they can access, which is in this case, the domain controller. And lastly, no wrap in order to have a copy paste format for the outputted ticket. So before we move forward, I want to explain a couple of foundational things. So firstly, SPN. What is an SPN? An SPN is a service principal name, a unique identifier for a service instance in a domain. It maps a service to a domain account. And we're using it, it's used for Kerberos authentication. The format of SPNs is that it starts with a service class. This is the technical term for what we call services, like the CIFS or the LDAP, or the time. It starts here, and then it follows with the host and the port if it's on a specific port, and then the service name. So example, HTTP is the service, and then the host is web server contoso.com. And here's another example. This allows a client to request a Kerberos ticket to authenticate to a service. It ensures the right account is used to decrypt the ticket. And it prevents ambiguity when multiple services run under different accounts. And to reiterate, time is not a useful service. That's why we're trying to change it to get CIFS, to get local access. You could also change it to LDAP to get AD access, and then conduct a DC sync attack, which I'll show you in a future video as well. A few key notes about the S4U attack. Firstly, because we're in a constrained delegation scenario, we don't actually need the user to auth to us prior to this attack. In an unconstrained delegation, we would, but in this case, we can simply ask using any user that we want. We don't need to coerce / trick any user or PC to connect to us. We simply go straight to the DC and request what we want to request using whatever user we want. Second point, alternate service name is a request. I actually just mentioned that. So we're not encrypting the desired SPN into a TGS. We're simply requesting it. And lastly, which I think is a very focal point of this attack, is that the desired SPN is not something that we need to encrypt, decrypt, like forging a ticket. We don't need to do that because the SPN itself, when we have the TGS, the SPN is in the wrapper around the portions that are encrypted. So that is in plain text, and we don't need to decrypt anything and recrypt it and forge anything in order to conduct this attack. So now that we got the ticket for the CIFS or administrator, we now need to create a context for that token. We create a process with the privileges that come with that token, the ticket that we just made for the administrator, put it into that process, and then impersonate it, use that process in order to do what we want in the access that we just made for ourselves with this attack. So we're going to be using Rubeus, create net only. Create net only makes processes for us, and I'll explain that command. As you can see here, we made the process with the ID of 5140. And right here, we'll see that again, we execute assembly of the Rubeus binary using the create net only command, which is going to start a process. Now, whenever you want to start a process, you have to specify what even is the program that your process is being made for. So the program that we specified is cmd.exe. In future videos on evasion, we'll talk about how to utilize processes and what kind of processes we should be making, and how we can use things such as process hollowing and other techniques in order to be more evasive in our navigation around processes. But moving on, we specify the domain, Contoso, the user, administrator. The password can be arbitrary, and then the ticket that we made. So now that we have this process ready for us to use in order to gain our new access, let's talk a little bit about token management. So you're probably familiar with simple impersonation. However, I urge you to use a different method in which you store the tokens that you make. For example, I just made this to access a specific PC. Instead of just, moving forward, impersonating it, and then moving to the next PC, and then going without any organization, let's go ahead and store the tokens in order to have them ready for us to reuse in the future if we ever need to go back to this access. So we just stored it, and now it's reusable. It's stored within our current beacon process. You can probably make something like a BOF to disperse it around, the target if you want within memory, but that's for another video. Anyways, now that it's stored, we simply use the same command, token store, with the use flag, specifying the ID, which is 0. And as you can see, we have impersonated it. Now, if you want to see all the tokens that you have, you can use token store and use sleep 0 to reduce the sleep time. And now that we did that, let's go ahead and confirm. Not run playlist, and as you can see here, we are administrator for CIFS on the DC. And at this point, you can go ahead and start attacking the domain controller that we just got CIFS access to. So to confirm that we have access to it, I go ahead and listed the directory. And that is the entirety of the video. This has been about alternate name service. We utilized our access on this workstation to enumerate for delegation. We then moved laterally to the target, which is allowed delegation, the web server. And from the web server, we abused the S4U and we abused Kerberos in order to gain access to the entire domain controller. So at this point, you can start taking over the domain, conducting attacks, conducting massive persistent attacks, such as golden tickets and so forth. And with that being said, thank you for watching this video. Please like, comment, and subscribe.